this episode of The Full Nerd, Intel's Tom Peterson here to talk ARC graphics. Welcome to a special episode of The Full Nerd. I'm your host, Gordon Ma-Ung, with co-host Brad Charkis.
Hello, Internet.
And special guest, Intel's Tom Peterson.
Hello, Internet.
And, of course, Adam Patrick Murray controlling the vertical and horizontal.
It's true. I'm here. I'm on my new verticals and horizontals, but this is just a test. This is just a test. I'm here. I'm excited to hear what Tom has to say. I was not briefed on any of this, so this is fun times.
Oh, this is cool. He's our test case. So, Brad, you want to go first, or can I go first?
You go first. You go first.
If I say anything that's stupid, just jump right in.
And then, you know what? Stupid is my specialty. That's what my wife tells me all the time. I am really special at that. So, Tom, I want to get into the most complicated subject here, which is the cores themselves. But since basically...
What are we even talking about? We haven't even said what we're talking about yet. Why is Tom even here?
Tom is... Oh, you're right. We should. If you don't know, this morning... the news finally dropped. We have the first Intel Arc GPUs coming out. They will be in laptops, but the same core architecture is across both of them. And what I want to ask Tom about first, though, is about the actual cores themselves. But in a way, so I'm a regular person, and I am unable to absorb the amount of render slices and all that stuff. What's the best way to explain to me what's super special about what makes up the core and the XE graphics?
Okay, Gordon. Well, first of all, let me just say thanks for inviting me back. I always have a great time talking to you guys. So you did mention today is a big day for us. It's like our first step after just giving birth to this amazing new technology after years of effort. Our engineers have been busily beavering along in the software and the dev tech. It's been a tremendous effort. So we're really excited to get our discrete graphics in the hands of our first customers, and I cannot tell you how gratifying that is for me. But back to your question, what makes our core special? Well, I look at it in a couple different ways. First of all, it's all about running existing applications really well. And we have some very fast, very efficient, very pipelined XE cores. The XE cores think of it as made up of two main units. There's something that we call a vector engine, and the other piece is a matrix engine. So if you are familiar with the vector engine, that's pretty much how all shader code is executed. It's SIMD, it's single instruction, multiple data, and it's meant to take advantage of what I've always called embarrassing parallelism that's present in graphics. You have lots of pixels, they all want the same operation to happen on it. So you just apply SIMD instructions, you run all the pixels through the same process. Everybody's happy. We just do that really efficiently. We share a lot of hardware. We get really fast clocks. It all works out. Trust me. Now, the second thing we've done is realize that we need a matrix engine. And the reason we need a matrix engine is because AI is everywhere. AI is disrupting every industry. It's becoming the most important workload for graphics other than gaming. And the truth is, we realized a couple of years ago that we need to run AI really, really well. And that's what the matrix engine is all about. It uses something that's called a systolic array. And the systolic array is all about how do we efficiently pass data between kind of intermediate calculations, all for one purpose, and that is to accelerate matrix multiplication. It turns out that matrix multiplication is the one thing that AI absolutely requires. If you're trying to do any type of inferencing, the core algorithmic processing is matrix multiplication. And a systolic array is sort of like the world's best way to do programmable matrix acceleration. And so that's kind of the core of it. We have a big L1 that accelerates kind of caching. We have a lot of advanced thread scheduling stuff. But I look at it as really that combination of three things: a great vector engine, a brand new giant investment for systolic and matrix acceleration, and then good L1 cache to back all that up with high bandwidth data reads. What do you think of that?
No, that's pretty good pitch. Is it? Go ahead, Brad.
There's RT cores in there too, right?
Yeah, there are, but I call the RT cores. Our topology is a little bit different. We have what's called a render slice. And the slice includes all the other stuff like geometry and RT ray tracing units. And each slice includes 4 cores. So think of it as Xe core is the hierarchy below render slice. But you're right, our render slice has a lot of cool technology in it as well. Hardware support for real-time ray tracing. You know how cool that is. So things like ray traced reflections and global illumination and ambient occlusion and all these effects just get way, way better if you can do really good hardware accelerated ray tracing. And that's what we've built. We also support DX12 Ultimate, which means we do things like variable rate shading and all the rest of the goodness that comes for DX12 Ultimate. So all in all, it's a render slice that's sort of our fundamental building block. And we dial down multiple different amounts of render slices to build our SoCs. And then we kind of derive our products from those SoCs. So the render slice is the fundamental building block, and Xe cores are like a module within the render slice.
So can we talk about how many render slices are in the products, I guess?
Sure. Well, the way to think about it is we have our architecture, which is Xe-HPG. That's like the high performance graphics architecture. And that gets embedded into our render slice. And then we build SoCs out of that. So we have 2 SoCs that we're announcing now. One is called ACM G10. The second one is called ACM G11. The G10 is the big one. The G11 is the little one. We have 32 Xe cores in the G10 and 8 Xe cores in the G11. And then all of the G10 has 256-bit memory interface for GDDR6, and the small core has a 96-bit GDDR6 interface as well. Both of them support 4 pipes for display. So they have 4 of our next generation display interfaces on each of the SoCs. So that's the way to think about it. We build 2 SoCs, and then all of our product stack, the actual chips that we sell, are derived from different configurations of those SoCs.
So you're calling them SoC, but why is it called an SoC instead of just a straight processor, I guess?
Well, because the way I think about it is, it's a system on a chip, which means there's a GPU and there's memory and there's IO and there's a whole bunch of blocks. So we call it a system on a chip rather than just a GPU. But the more important thing is that SoCs are the silicon that we build, and there's multiple variants of products that are derived from each of those chips. So I like to specify and differentiate the SoC constructs from products.
Okay, speaking of the chip, you guys are doing really interesting stuff with all the other stuff that are on that chip, including the display engine and media encoding engine and all that stuff. You guys are the first GPUs to support AV1 encoding.
Yes, we are. We're super excited about that. Go ahead, Brett.
So yeah, you go ahead. And then if you don't answer, I'll follow up.
All right. So we are the first GPU to do hardware encoding, hardware acceleration of AV1 encoding. If you don't know, for the folks, AV1 is sort of the next generation video codec standard. It does lower bit rates or higher quality at the same bandwidth and gets you basically a better streaming experience. And it's where a lot of the streaming services and a lot of the ingestion services are going to go. We've already done integrations with FFmpeg and Handbrake and XSplit and others. And you can already see just from those integrations just how much better the AV1 encoder is going to be. So we're pretty excited. We're kind of leading the way and saying the industry is going to be changing because it's just so much better. And we're the first to kind of invest in that additional hardware.
Yeah, and so up to now, because any AV1 encode they're using a Handbrake, that's all host based, right? So
it's all CPU based.
All CPU based, generally not that fast.
Yeah, this is about 50 times faster.
Wow. Okay.
Cool.
Yeah.
So that kind of ties in. It seems like this launch, you guys are launching first in these laptops, Arc 3 laptops. A lot of the features you guys are really proud of and showing off, it felt like, are involved around content creation kind of stuff. Mm-hmm. AV1 encode sounds awesome. You guys have all these deep link things like hyper encode. Deep link basically has Intel CPU, Intel GPU working together because they're all Intel. You guys have a thing called hyper encode that basically lets like Handbrake or whatever work together. It lets the two GPUs work together and do the task.
Absolutely.
That,
Okay.
I tested that in the initial form with the XE Max laptop when it came
Yeah.
out, the Acer Swift 3X, and it like absolutely crushed single GPU performance. Like even with the XE Max and the integrated graphics, it crushed RTX 2060 laptop. This seems like it could be a really compelling platform for creators. Is that like a big thrust for you guys?
Yeah, absolutely. The initial models are going to be perfect for creators. It's like a creator notebook that you can create on the fly, but you can also play games on, which is a nice benefit. But let me come back to this deep link thing, because that's one of the things that got me most excited when I joined Intel, believe it or not. The idea that Intel has a 30, 40 year kind of portfolio of technology that they've been building that we're now applying in dramatically different ways with the presence of a discrete GPU that we can optimize. So we have this thing called hyperencode, which is taking advantage of all the encoders on the system. We have another thing called dynamic power sharing, where we're looking at the CPU and the GPU and making decisions about how to shift power from one to the other. By the way, that technology that we introduced today is just at the very beginning. If you start thinking about the general way people describe their platforms, they'll say, "Oh, this game is CPU limited, or this game is GPU limited." That actually turns out to never be true. If you look within the frame, like there's times within the frame that you are CPU limited, or there's times when you are GPU limited. So what we're looking at is, how do you start getting more predictive, and how do you start shifting power on a really tight time scale so that you can really wring out that last level of performance? So this is the kind of stuff that I get excited about: hyperencode, dynamic power sharing, and even the multi-compute engines, like where we're doing that DaVinci Resolve, showing how we can do sharpening using both kind of resources on the CPU and on the GPU.
Yeah, I was going to ask you if you could talk about more about that specifically, because dynamic power share and hyperencode have been around for a bit. They've obviously been getting better since the ZMax came out, XEMax. But hypercompute is new to me, at least.
Yeah.
What are some of the practical effects of that? Like, what at a practical level? Like, this is a consumer laptop launch that we're talking about. What can a person who buys this laptop? What can they expect to get out of hypercompute?
Well, hypercompute is all about taking advantage of all the different compute blocks that are available in your system. So if you have an Intel CPU, inside of that guy, you've got kind of an integrated GPU that has a pretty beefy compute engine, right? They've got vectors and they've got lots of DP4A support. And now you've got next to that this XMX block that has a heavier, sort of more matrix accelerated style. So can we leverage both of those to do a common problem? The answer turns out yes, because we've built a middle layer, I think it's called MLS, that does scheduling across all of the compute blocks that are available in your hardware. So this yields kind of the best of both worlds. A large majority of notebooks are shipping with Intel processors today. And now when you connect those with the new Intel discrete engines, you're going to get basically free performance. And that's what the hypercompute technology does.
So, Earl, I have a question. So you were talking about the dynamic power sharing, because right now it's basically adjusting in milliseconds.
Yeah, every 100 milliseconds right now.
But it sounds like when you say within the frame, as we move forward, as we're going to get to the point, we're already at that point where, frankly, most of the CPUs are hitting boost clocks you can't even see because they're so short. So is it possible we're going to get to the point where you're shifting performance in the microseconds, even down to the nanoseconds? I don't
know about nanosecond, right? Because there's some system level constraints that are going to make a nanosecond problem hard. But I will say that I have a general belief that says the faster we can make decisions, then the less margin we leave on the table. And so to make faster decisions, it costs something, right? You got to get better monitoring. You got to build better hardware systems. So there's a cost. But the benefit is you're extracting this extra, performance parallelism. And what that trade-off is, we don't know. But I got to believe it's faster than 100 milliseconds. And we're kind of heading that way.
Wow. Huh. And and this dynamic power sharing is not a Windows thing only. That'll be across other.
Yeah, that's across. Well, right now there is a driver element that is the algorithm that's running under Windows that does this dynamic power sharing. But again, this gets back to, well, you don't want to do, sub-millisecond decision making using a Windows driver. You want to have something a little bit lower level. Maybe it's in the firmware, maybe it's in the hardware. And I feel like this is just at that, really we've taken the first step. And that's the way I feel about a lot of this stuff. Our products are fantastic, but it's just a gigantic first step for us. And as we start doing more of this platform level integration, I really do think the sky's the limit.
All right. While we're talking about speeds and feeds and stuff like that, I had just was wondering if you could talk about the clock speeds, because if you take a peek at these slides, like at first blush, it seems like, hey, 900 megahertz for one of these. It seems kind of low. But you guys are using a totally new metric to calculate this stuff, and I was wondering if you could explain that a bit, because I think that might cause some confusion for folks.
Yeah, I'm not surprised, and we've debated this long and hard. Brad, the point you're bringing up is we've defined a new metric or a new spec that we're going to call graphics clock. And what the graphics clock refers to is sort of like the expected clock or higher that you're going to see on our worst case TDP environment. So when you look at our SKUs, especially for notebooks, some of those SKUs have very low TDP numbers associated with them, which means that the clock is going to be more constrained. And so in the worst case app and the worst case thermal environment, you're going to see a relatively low graphics clock spec. Now, most of the time, when you're running in a little bit freer environment, you're running a little bit lighter workload, you're going to see higher clocks, even on the low-end SKUs. But the problem is, how do you set expectations correctly for gamers? If I tell you that we're going to get a 2 gigahertz clock all the time, and you start seeing 1.5, 1.4, you're going to be like, hey, this is not what I was promised. So from my perspective, I'd rather be conservative on clocks and over deliver on the runtime experience. And if people make their decisions, hopefully people will learn, what does it mean when Intel says graphics clock? It means that it's the typical clock you can expect to see on our worst case thermal environment, running effectively within the TDP envelope of the worst case specification.
So it's kind of like a base clock, like for CPUs?
I mean, if you think about the way the green team does it, it's actually closer to boost clock. So it's not quite base clock. It's really not quite boost clock, but it's definitely not peak clock either. It's something in the middle, which is kind of trying to be as transparent as we can about what we expect clock behavior to be. I would say there was a debate that we were having about, do we need to be talking about clocks at all in this moment, where really it's more about delivered platform performance, and it's about what the reviews say. So what is the clock adding in this conversation? But at the end of the day, it turns out to be important, especially as we start getting towards more discrete graphics cards, right? Because this is where sort of the clock wars will get more intense.
Yeah, and I do think like it is a problem because people can't compare Team Red clock versus Team Green clock, and now it feels like you just got to here's Team Blue clock. You can compare it within the same family, but not against each other is what people
It's very true, Gordon. That's the way I think about it as well, where we're trying to say we're measuring these clocks all the same method for the blue team. Now, what the green team does or the red team does, I can't really speak to that. I mean, I shouldn't really speak to that, but I can say that what we're doing here on Team Blue is meaning to be as transparent as possible, and yet still give you a sense as you go up the stack of, if a number's higher than the other one, especially if it's in the same family, then it's going to tell you which one's going to be faster. So
you mentioned the clock speeds will matter when you get to desktop processors or desktop graphics chips, et cetera, et cetera. Yep. I was wondering if you could talk to why you guys decided to launch in laptops, especially more affordable laptops, before going out with the higher versions.
That's a fantastic question, Brad, because it's going to the core of what is Intel all about. So we're taking a very measured approach to this. We're starting from our strength, which is we ship the majority of notebooks, and we want to make those notebook platforms just that much better and make sure, we can do all the platform integration that everybody expects from us. Excuse me again. So that's the way I look at it. You can see the history of innovation everywhere from USB, Thunderbolt, Wi-Fi, and now discrete graphics plugging into that platform, doubling performance gen on gen. Discrete is going to be a totally different bag. right? Because we're entering a market where there's strong entrenched competitors that have had a duopoly for a long time. So we're going to be very humble, and we're going to come in, basically saying, hey, we're pretty excited about where we are, and we're excited about the future because we're getting our sea legs, right? We're kind of getting our game going. And right now we're pretty excited with where we landed, but we're even more excited with where we're going.
Should we, and actually we probably should add them on. We'll show the slide so we don't have to go over the actual model numbers. We've got ARC 3, ARC 5, ARC 7. So we're going to see ARC 3 first. Basically, is that today, I guess? This is available starting now?
It's available starting now for pre-order. You can order the thing today. But you're going to see a lot of additional models showing up in April and May. And then later this summer, you're going to see ARC 5, and ARC 7. So we are in the market. We're playing the game. We're going to see what people think about our graphics, and I'm super excited about it.
So you're the newcomer here. So pardon, don't offend you, but people only speak this way. Like people go like, well, is ARC 3 a 3070 or a 3080 or a 3050 or an MX? That's sort of like, or compared to Radeon, or they always, that's the only way people think is the existing products. Where does ARC 3, who's that going to fight against?
Well, let's start with the way I think about it, and then we can talk about what reviewers might say or press might say. The way I think about it is we're here to deliver a great performance for a notebook platform. And what we're focusing on is, hey, can you play the top games that you care about at the frame rate that you care about? And can you do it in a form factor that's awesome? And can you get a price that you like? So that total solution is kind of our first priority. Now, I know reviewers are going to ignore that entirely, and they're going to go off and run their performance benchmark. So I don't want to prefetch that, and I'm going to basically say we know that no matter what we say on benchmarks, it's almost it's not, take it with a grain of salt. You're going to go do your own thing, and I encourage you to do that, and then we'll see where see where we lie. I think it's going to be interesting because our belief on ARC 3 is it's about the experience that we deliver for that category of user, and then obviously as you go up the stack, you're going to see higher performance.
So during the presentation that I was privy to, basically it breaks down as ARC 3 laptops are going to be roughly 60 frames per second or higher in AAA games at medium or high settings at 1080p, and over 90 frames per second in many of the top esports games.
Yes.
But these first ARC 3 laptops, they also said a lot of them are going to be Intel Evo models. So should we expect these laptops to be just as thin and portable as previous Evo laptops?
Yes, you'll see the Evo platform itself sort of defines a thin and light form factor. There are no like big chunky Evo platforms. So we live within that TDP constraint and still deliver the performance that's required.
Oh, that's interesting.
Yeah, you can see on the TDP power numbers that we gave, the ARC 3 is between 25 and 35 watts. The 370 is between 35 and 50 watts. So we're talking a power constrained graphics device. And that's why we can afford to fit into these thin and light Evo platforms.
All right.
I'm, and you're right, because reviewers are the ones that that generally sort of set the world what they expect. But I kind of wonder if it's going to be this interesting thing where, like in some things, you may clean other competitors' clocks, because if you do an AV1 encode,
you're going
to crush everybody because they don't have hardware AV1 encode. So how do you weigh that? And it's, versus pure frame rates?
I think the market is going to shake all this out, Gordon. I really do. People are going to be, if you're a creator and you're looking for a thin and light laptop that you can do all your content creation on, and you want to play some light gaming in the evening, and you're like, I wish I could do this all in one device. Well, this is kind of the device for that. Excellent battery life because of power sharing, hyperencode. I feel like it's kind of the perfect product for that particular consumer. And it's a good place for us to start because it leverages a lot of the technologies that we can bring to bear for creator. And also it leverages our deep relationship with ISVs. And we can get these things like, the compute sharing and the hyperencode stuff done.
So to me, the really important message of, performance on Windows and on the PC going forward is it is about developer relations. It is about having optimizations from, independent software development, ISVs for your hardware. And you know how hard that is. Are we going to be there on day one for Arc, and is it just simply going to be one of those things where it'll take 5 years to get developers to board the train?
I don't think so. I think you've already seen that we've announced several of the availability applications for AV1 encoding as an example, and hyperencoding. And we've also showed you the DaVinci example on the compute sharing kind of stuff. So I feel like you're right. On the one hand, first, let me give you're right. It is all about developer relationships and dev tech and integration, getting the right technology inside of the game so that they can leverage your hardware. But the more that we can do by providing middle layers of software like MLS that make all of that easier, that's key. And the good news is this is kind of where Intel is super strong, right? We have a long history of open standards and working with the software ecosystem. We love Linux. We are all about what's the best way and the fastest way to accelerate the software ecosystem. And sometimes you got to do that heavy lifting yourself, where your dev tech engineers are kind of like partnered up with the individual ISVs, but it's even more powerful if we can find ways to do these layers that accelerate things, kind of like OpenVINO. OpenVINO accelerates all kinds of media, and it does it now in a way that it's aware of multi-compute engines.
And it's open too, right? OpenVINO.
And it's got open in the name.
It's got in the name, right?
Says it right in the name. Come on.
I am interested because you do have, one of the things you cited was Topaz Video Enhance, which it's a really awesome application, but running it on the CPU is pretty painful. So yeah, I'm really excited to see how Arc does with it.
I think it's going to be good. I mean, I've seen multiple demos where, it's kind of night and day before and after. It refreshes your old videos and your old photos, and it makes them look like, hey, this is something I wouldn't mind showing, wouldn't mind taking a perusal of. So they do things that are also using AI. So they do the denoising, and they also do the upscaling and upsampling. And the output of the videos using all these different compute blocks is just beautiful.
Yeah, I've played around with it too. It feels like magic sometimes at the end.
Yeah, it's super cool.
So, touching on that, I agree that Intel has super strong software developer relations, like hyperencode, hypercompute, all the steep link stuff. I have no doubt that you guys will get adoption pretty quickly. I'd be surprised if you didn't. You guys are new on the graphics side of things, though, and XeSS is brand new technology, obviously coming out, which does in fact tap into those XMX cores and take advantage of all that. What's XeSS going to be like on day one?
Well, we've announced 14 titles that'll be available with the mid-range of the GPUs when they become available. We're doing integrations right now that are just going really, really well. We have an SDK for doing an XeSS integration. We got folks engaging with lots of different tier one titles. And the good news is that because of what XeSS is and the way that it interfaces with the render pipeline, it's very similar to other types of graphics technologies like, temporal anti-aliasing. And so because of that, the integration with ISVs is actually relatively straightforward. There's no resources that they've never exposed that they got to go figure out where they are in the pipeline. This type of integration has been done before. Now, I think that as we start going forward, there is a question about how do different effects that are constantly perturbing, different game developers, can we do something better that's going to be less disruptive going forward? And I hope the answer to that is yes. And we're looking into several different avenues to do that, so that, the faster this cycle runs, where we develop a technology, it gets integrated into a game, and then users can use it and experience it, that cycle, the faster that runs, the better for everybody. And that's what we're trying to do.
Just last week at Game Developer Conference, NVIDIA announced Streamline, which is kind of like an open framework to encapsulate all these different upscaling options. Yep. And you guys were the first one out of the gate supporting that. So what are your thoughts around that program?
Well, I obviously I know all those guys, and I'm pretty optimistic. I feel like it's the first time that we've tried to partner with NVIDIA like this, where we're kind of having a common cause with ISVs. We have a lot to figure out yet. This is sort of like in its very beginning, but from a technologies perspective, we're definitely trying to solve a big problem for ISVs, which is I've got all these different vendors coming to me. Everybody's different. they're all very similar, but I still have to rip up my code and I have to do all the verification. Can you make this easier? And that's really what the technique that we're talking about with this new open interface is trying to do. Now, can we find a way to work with NVIDIA effectively? I really do hope so. And all indications are that we will be able to. But don't get me wrong, that doesn't slow us down on any of the other things we're already doing. We're moving full speed ahead with our XeSS integrations. And maybe someday this new technology will arrive and it'll help solve problems, and we'll support that as well, is really my view of this.
All right. Go ahead, Gordon.
Can I ask
I've been
about
hogging.
you had a couple of new sync technologies that you're introducing with Arc.
Yes.
Can you explain which situation you'd use them in? Because
yes. So the ones you're referring to, there's actually sadly named 3 syncs that we talk about with Arc. Okay. The number one, sadly named Adaptive Sync, which I still am not a big fan of that name, but that's the Visa standard for how variable refresh rate technology works. And Adaptive Sync, we 100% support. I'm very passionate about variable rate interface technology, and that is going to work 100% on Intel Arc. So that's in the bag. Now, the problem is when you don't have an adaptive sync monitor, you've got some problems. So Speed Sync is our first technology that we're going to be talking about. It's an Intel-only technology, but it's a pretty simple thing to understand. When you have a high frame rate game that's running at like 180 or 200 frames per second, and you turn VSync off. The reason VSync's off is because if you turn it on, the frame rate will drop and your latency will explode. So most esports players have VSync off and you're running really high frame rates. And what that does to your screen is you get this sort of like tearing everywhere. Because you're having really high frame rates, you get multiple tears per frame. And it absolutely looks like, not great. So the solution that we've come up with is effectively to do frame subsampling. And what that means is we've virtualized the swap chain, and that means behind an application's back, we're going to say, hey, VSync's off. So go ahead and run full speed. Don't pace anything. Just spit the frames out as fast as you can, and we'll flip to them. Well, under the covers, what's really happening is we're showing full frames. So we're just going to show one frame, and they're going to render multiple frames underneath it, and then we're going to pick one. We're going to show the next frame. So you don't have any tearing, and latency is very, very low. That's the benefit of Speed Sync, and it's targeted at these games that have really fast render rates. The third technology that we're talking about here is Smooth Sync, which is, again, a completely different animal. Smooth Sync is really targeted at games that have a slightly lower render rate. But you still, you're not turning on VSync because it would make it even chunkier. So now, how can you make that experience better without a variable rate monitor? And what we've actually invented is pretty cool. Inside of our display engine, we actually have a few scan lines of data. So what we're doing with that data is saying whenever a tear is about to happen or whenever a tear has just happened, we're going to blur from the prior frame to the new frame. And instead of having the stark tear line, there's going to be this gradual fade between these two frames. And what that does is it kind of gets rid of that acceleration that you see when you see this tear line. Your brain goes, oh, that's weird. Something just jumped. By blurring across that boundary, you can make it a much softer experience for your eye, and you don't get as disrupted by tearing. So both of those technologies are Intel only, and they're going to be shipping with Arc when we launch.
And they both go ahead.
That's really interesting. I can't wait to try that out in practice because it's that hard cut that really messes with your eyes. So I'm really curious to see if this makes a big difference.
I mean, I did do a little research about this some time ago where it was sort of like monkey brain stuff where your eyes are somehow evolved to detect really sharp motion and changes in acceleration. And what a tear line does is your brain is saying something just jumped, right, in position in space. I expected the head to be here, but it's actually jumped to the left, and your brain goes, "What the hell?" so by blurring that a little bit across that boundary, you can kind of tamp down that deep monkey inside of your brain, and hopefully, we're going to see some gamers that enjoy the technique.
That's passed on for millions of years. Of that, last thing you see is the lion's jaws. Like, oh, it's tearing. Oh, no, okay,
that's exactly right, Gordon.
But they both really sort of prioritize latency. So you'll still get the latency benefits, but less jarring is what it sounds like.
Exactly. Neither of these technologies turn VSync on. They're both VSync off. you're running your render pipeline at full speed, and you're getting the lowest possible latency. We're using our hardware section of the display block to do this whole blending thing. And in the other one, we're using the virtualized flip buffer, the virtualized swap chain, to effectively subsample out of the kind of the final rendered frames.
So speaking of brains, SpeedSync sounds somewhat similar to NVIDIA's FastSync. Which,
Brad, that's an interesting observation. It does sound very similar to me.
It does. And if I remember correctly, you were the one who presented that at the GTX 10 series launch back in the day. So you keep saying adaptive sync is a personal, love of yours. Is something like SpeedSync a personal love of yours?
I love it too. I think they're great technologies. Yes. But I don't want to take credit for any of it. It's just part of a bigger team, right? And everybody's working on trying to make the gaming experience as good as you possibly can. And we're not done, right? There's millions of hey, good news. Intel is in the game on gaming, and we're a very rich, kind of like broad company with lots of different techniques and lots of different ideas. And now we're laser focused on making these experiences better. So you can kind of assume that, these are pretty cool, but there's more to come.
Yep. Along those lines, I was wondering if you could talk a bit about, and this again leverages you guys' XMX AI technologies. You guys also have the new Arc Control overlay and management software, which is great. Love to see it. One of the things that interested me about it is the fact that it does have so many AI tools inside of it. It has various AI broadcasting tools, but it has automatic game highlights too that's handled by AI in some way.
Yeah.
Could you talk about that? That's interesting.
Well, the idea is, we ought to be able to build a network that is just like you and me. I often say, if the human can do something that you can explain to somebody else, then it's probably likely that you can train an AI network to do the same thing. So if you're watching a stream and you see a bunch of gameplay that you're like snoring through, but then all of a sudden, somebody starts bashing on an enemy and you start seeing lightning flashing everywhere, this is a highlight. So effectively, we can take that kind of training where you say, this type of gameplay is not that exciting, but these moments are very exciting. And you can train a network to recognize that. Now, once you've trained a network to recognize this different gameplay intensity, you can use that to trigger capture. And that's really what Game Highlights is all about. It says, based on a certain type of activity that we've learned represents exciting gameplay, let's turn on and turn off our capture around that.
Awesome.
Yeah, it's pretty cool. Now, the other thing I don't think we mentioned in the presentation, but I want to make sure everybody knows, is that everything that we're doing in Arc Control is done through APIs. So Intel is a very open company in terms of our APIs. There's a new API called Control API, which is not a surprise. It's actually out there now. You can take a look at it. And that is the way that third-party applications like Afterburner or Riva Tuner or any of those kind of things, ASUS's thing or MSI's or Gigabytes, all of those applications can use this API to access the same GPU functions that you'll see inside of Arc Control. So that's pretty cool. We're basically saying Arc Control is our reference. It's pretty cool because it does a real-time overlay, has very low overhead. It's very, kind of zippy. It does all of our driver download stuff. But if there's a third party that wants to get in the game, we make all of that available to them directly.
That's rad.
I just need to ask, even though I know the answer, but for the port nerds, because people want to know about the ports, what port specs do you support? Because there's somebody
port nerds on display.
Yes.
Okay, so display, we support DP 1.4a. And let me see if I can pull it up here so I don't misspeak. DP 1.4a, we HDMI 2.0b, I think. Mm-hmm. Yeah, and let me see one more here. HDMI 2.0b. And then, the cool thing is we do 2 8K 60 HDR and 4 at 4K 120 HDR. And then we even do early support for 2.0 10 gig on DP. So that's a future kind of thing. The spec's not completely solid yet, but we do think we're 2.0 10 gig ready on the DP. So,
And that's even on these more affordable Arc 3 laptops?
Yep. Same. All the SoCs have the same 4 display pipes. Now, of course, it's up to the OEMs and their chassis about how do these ports get pinned out, but the technology is enabled on the SoC and on the chips.
And then also, how's it plumbed? Because I know that the Arc 3 is, I think, on it's 8 lanes of Gen 4?
Eight lanes of Gen 4 on Arc 3.
And then 5 and 7 are 16, I think?
16 lanes of Gen 4 on Arc 5.
Yeah, on Gen 4. What? Because I'm just interested because I'm not sure how that works out because Alder Lake is 8 lanes of Gen 4. So
the displays are directly off of the GPU, right? So the configuration when we're connecting to these 4 heads does not go through Alder Lake.
Oh.
There's a whole bunch of local connectivity. Yep. There's still going to be these hybrid configurations that have displays that connect off of Alder Lake, but that's not really what we're talking about with the native ports off of Alchemist.
Cool. And then I want to ask because I know there's something else coming supposedly that is desktop tees. What can you say about that today?
Well, I cannot say much about that except that there's a desktop tease, and if you watch the video, you will see the tease.
Worth a shot.
I gotta say, I'm excited. You can tell I'm excited. Look at me, I'm excited, and I've been waiting for this for a while. So pretty cool.
That is actually kind of like one of my winding it down questions is it too late now? Because I know people have been like just screaming at Intel, please get these things out to us. We haven't been able to buy GPUs for two and a half years now.
Yeah.
It feels like the pressure is getting, not as bad. I don't know where the supply is suddenly coming from, but now it feels like, oh, maybe things are getting better. Is there enough? Is the window still going to be there, or is that not even a factor in Intel's plans for?
I don't think it's a factor for me. And for Intel in general, it's not a factor. We think that being in the discrete GPU business is critical for Intel long term for many, many different reasons. And right now, there's been this weird glitch with mining and consuming a lot of GPUs that's led to the artificial price elevation and capacity constraints. But I'm glad to see a lot of that's easing up. But at the end of the day, I think it all turns out to be what's the capability that we offer, and is it going to be something that our customers desire? And then we'll sell our fair share. And if we price it too high, we'll sell less. And if we price it low, we'll sell more. So at the end of the day, Gordon, I'm a firm believer in the market is going to figure this out. And if we happen to launch into an extremely high GPU priced market, we're going to do what we can to try to get our GPUs into the hands of gamers. And Raj has said that, and I applaud him for it. It's a very difficult thing to do, and maybe we won't need to do it because the market will normalize before then. But I don't expect it to completely. So, like Raj has said, we're going to do our best when it comes time.
Do you have time for kind of a pie in the sky question, or do you have a hard out in 2 minutes?
Brad, I'm here for you, man. You can.
All right.
Pie in the sky me.
All right. So during the press briefing, you used the term neurographics a bunch, which I found pretty interesting.
Did I? I don't know.
So you're basically talking about how, blending AI with traditional render tests, which last time you were on the show, you talked about that quite a bit. Like, you seemed really excited by that as well, just as excited you were just saying. Yeah. You're talking about the Nirvana is AI's hallucinating fully without traditional render stuff. You were talking about, maybe we could get rid of tessellation. And
Jesus, did I say that? That's crazy.
Stuff like that in the background.
That's crazy.
But Raja also, you just brought up Raja. He also brought up, he did a Powering the Metaverse post back in December, talking about how we need to reach 1,000 times the power of today's, high end, what we can do. You guys seem to be betting pretty hard in AI. Do you think that's a major slice of powering the Metaverse vision?
Well, I'm going to defer Metaverse to Raja because he's a lot more versed in that than I am. But I think we all agree. Anybody in the industry agrees that AI is the most disruptive thing to arise since effectively the Industrial Revolution. And I would not say that stuff lightly. It's disrupting every business. in every category. It's making new winners and it's forcing new losers, right? So I feel like AI and graphics are a natural mate, and not just AI and graphics, but AI and you pick your name for pretty much anything else, and it's going to be big. Trust me, it's going to be big, and that's why I talk about it when people, when I get the chance.
All right.
And I think that this whole idea of can you someday have an AI that's doing more than just upsampling, I think that is a very, very clear yes on you will have AIs that do more than just upsampling. Because if you think about it, the idea of I have metadata that's represented by a frame, it might be more like a game engine that says, hey, I here's my set of data that represents the frame I'm about to draw. And instead of taking that data and putting it into a render pipeline, if you could have the state plus that new metadata and give it into an AI and it spits out the new frame, I mean, we are decades away from that kind of stuff, but that's the idea, right? How much of that pipeline really makes sense to move into AI? And it's more than just upscaling.
Wow.
All right.
Yeah. A little bit on the way out, right?
Yeah, I can't think of anything better to think about because that's going to be amazing. Of course, it's decades away, but
basically the way I think about it is we've come all that way with ray tracing and all the work that the game engine guys are doing, working now with the film industry. If you think about this whole thing, it's becoming converged between movies and CG and then real-time graphics. So the next step beyond that is like, well, maybe how do you redo the content pipeline? Because the content pipeline today is still just a mess. It's very difficult. And you'd like that to become much more, take the hard work out of it for the content creator and put AI in the place of that.
No, I mean, why go to the movies? You just simply can. I mean, that's what video games, that's what the movie industry has been so worried about video games for such a long time, because you're playing a 50-hour movie interactively in a lot of games.
Pretty soon it's going to be more difficult to tell. I don't think we're quite there yet, Gordon, but honestly, we're not decades away on that one. Yeah.
Maybe Michael May will make a video game next.
You never know.
He can put more explosions in that way.
So there's some more speculation. That's 2 speculative comments at the end.
Do you have any more questions, Gordon?
No, I mean, this is just all like I just kind of want to see the hardware, and I think you're right. I think we're going to have to get it into people's hands and see how people judge it, and that's ultimately what matters. I just hope that everybody can always interpret a new part correctly, because I do think the sexy part of this really is on the AI and content creation side, which I'm really excited for it, because
I'm also really excited for it.
Right? I mean, if you're going to AV, I can tell you immediately that in AV1 encode, if I'm certain it'll be crush the competition, including the ones made in Cupertino, and right. So I think it's, and then how do you judge that value?
Yeah, it's hard. It's hard.
It's very hard for a reviewer.
I would say we're in a platform world, right? Where we used to be thinking about, oh, you know what? I'll just do an FPS chart. And the truth is you can still do that. And we're not going to, I'm not going to fault you if you do that, but there's a lot more going on, and people are making purchase decisions for a lot more than that, especially in this segment, right? When you look at the Creator Thin and Light notebooks, people are like, yeah, FPS, but maybe I'll turn on, Counter-Strike once in a while, but really I'm all about what's my transcode look like.
Right. And how fast, and again, like using Topaz Lab stuff, all the AI. Yep. It's really a big, huge blind spot that I think is kind of missed by a lot of traditional meat and potatoes kind of games reviewers. Yep. So
we'll see. There.
We shall see.
It's your new thing.
Check back next week for your fix of PC talk on The Full Nerd. For audio listeners, subscribe to us on iTunes, Google Play, Spotify, or Stitcher. Send questions and comments to thefullnerd@pcworld.com. And if you're on one of the services, please do leave a review. Every time you do, we get a new entrant to the GPU marketplace. Thanks for coming. I'm Gordon Ung with Brad Charkis.
Adios.
Tom Peterson.
Thanks, guys.
And Adam Patrick Burns going to hit the off switch.
Always great having you here, Tom. Thank you so much. I appreciate it. And we will see everybody later. Bye.